So we're going to finish 10.5 today, and we are going to be learning a few things on the calculator today. We'll go over that specifically. And yesterday, just as a reminder, we wrapped up, we finished by finding the inverse of A by using our elementary row operations. And we got the identity on the left side, which left us with the inverse on the right side here. So this was our inverse of A, which is where we left off. And you guys actually finished the whole thing, correct? Yeah, I feel like we finished that in class. Okay, so if you end up with a row of zeros on the bottom left of a matrix, then there is going to be no inverse. So there is an example in the text. It's on page 676. We're actually going to write that out so you can see an example. So if you were trying to find the inverse by converting the left-hand side to the identity, and you did all this work, this is the exact one in the book. And 1. Okay, so let's say that you manipulated, you got the 1, 0, 0, 0, 1, 0, and then this happens, where you have these 3 zeros on the bottom. Now, there's nothing I can multiply by here to get this to be a 1. This 0, 0, 0 situation, if that happens, that means there's no inverse. Can you guys think about why you wouldn't want to like add the bottom row to the top row and have that be your third row? Yeah, when you add, you do 0 plus 1, which would be 1, and you don't want your leading 1 here. Okay, so if it happens where you have the 3 zeros here, that means there's going to be no inverse. Okay, so yesterday we did a bunch of operations by hand, and today we're going to start to talk about matrix equations. And for matrix equations, we are going to learn how to do some cool things on the calculator. So first we have to go ahead and go through some of our terminology. So for matrix equations, let's say we're given this system. The matrix equation is going to be this right here. This is called the matrix equation. So in examining this, Bruno, where do these numbers come from in A? Yeah, they're the what? Okay, yeah, they're the what? The coefficients, right? So in front of x is 1 and then 2 and then negative 3. So when my x's are 1, 2, negative 3, those are my coefficients of x. In the second column are the coefficients of what? Y. And then the third column, the coefficients of z. And then we have this matrix here, the x, y, z, the variable matrix. And then that's going to be equal to 7, 5, 0, which are going to be the constants. Okay, so one thing you're going to have to do today is take the system and write it as a matrix equation. If we let that first matrix be A and that second matrix be X, the last one we call it B, then our matrix equation is AX equals B. And that's going to be important when we talk about how we're going to solve it. Now, matrix A is called the coefficient matrix, which makes sense because we just talked about how it's made up of all the coefficients. All right, in the next slide, we're going to talk about how you solve. So this is our equation, okay? A times x equals b. Now, usually, if you want to undo something, you want to use the inverse operation. So what you could do here is you could multiply each side by the inverse. So if I multiply an inverse by A, what do those do to each other? Yeah, so, okay, so there's two ways you can think of it, right? An inverse, when multiplied, is always going to undo it, and then Jonathan, in this case in particular, it's going to make what? The identity matrix, right? So if I start with AX equals B, if I want to multiply this side by the inverse, notice that this does not have B times A inverse. Why is this not going to be the same thing? Yeah. Okay. What in particular? Okay, yeah, so the order matters because the multiplication is not commutative, right? Okay, so when you're going to multiply, you have to multiply on the same side. So if you have the inverse times this side, you're also going to have to do the inverse times this side in the same order. So they would both have to be on the left. Right? So then once you multiply here, this is going to create the identity matrix. Well, we learned yesterday that whenever you multiply something by the identity matrix, what are you left with? Itself, right? Right? So we would just be left with x, and on this side, we would have A inverse times B. Okay, so if you start out with A times x equals B, you know that x is going to equal the inverse of A times B. Okay, and that's an equation that we're going to use today. All right, so this is in example 4. We showed what the inverse of A was. So we're just pretending that this is given to you, okay? If this is your inverse of A, then what you can do is multiply that by B to find your x, y, and z. Now, you could also do this by hand, and I'll just show you how we could do that. So this is a 3 by 3 matrix. This is a 3 by 1. So can we multiply those together? Yeah, what's our result going to be? A 3 by 1. Okay, so those match. So our result is going to be a 3 by 1. Okay, so then I can multiply the row by the column. So if I find the first row, first column, it'd be negative 3 times 7 plus 2 times 5 plus 0 times 0. So negative 21 plus 10 is going to be what? Negative 11. So that's going to be the first row, the first column in your solution matrix. Okay, and then we could do the first row, the second column. Or sorry, yeah, the first row, or we don't even have that one. So now we're going to go to the second row. We only have one column, so we'll go to the second row, the first column. So that would be negative 4 times 7 plus 1 times 5 plus 0. Because negative 2/3 times 0 would be 0. So negative 28 plus 5 is going to give you negative 23. And then now we have the third row, the first column. So it'll be 1 times 7 plus 0, which will give you 7. Okay, so this is going to be your solution. This is going to be your x, y, and z. And when we're using matrices, you can actually write your solution like this. Yeah, John. Okay.
So on slide 22,
Mhm.
20,
Yep.
they factored x, y, and z. Can you just fill in any table matrix, just like background numbers, just like we did?
Well, it's the system. So if you were to multiply the system out,
Yeah, it would come up to be exactly the same.
yes, yeah. So it would have to be a system with the x, y, and z in it.
But let's say all the first column had a 2 in common. So could we write a 2 instead of the x, and it would just reduce all the first column by 2?
Oh,
That's what I mean by that.
yeah, you could, but then when you're solving,
I mean,
it would be 2x equals the final value, and you'd have to divide. So don't do that even if they have a common
no,
factor.
I was trying.
Yeah.
And for what we're doing right now, why
Yeah.
don't we just include X, Y, and Z? Why don't we just solve it as
What do you mean?
like just put it in reduced row echelon form,
That?
solve for X, Y, and Z?
Well, really, you could. Yeah, really, you could put it in reduced row echelon form and solve that. Absolutely. Okay, and then we are going to flip over to the next one. Okay, so for your matrix equations, our solution of the original system was -11, -23, 7. So this is how we wrote this at the beginning of our chapter here. When you're doing the matrix equation, you can go ahead and just write your solution as the column. Okay, as the -11, -23, 7. That's perfectly fine. We've also proved that this matrix equation can be solved using the following method. So what we did is if A times X equals B, then we know that X is going to equal the inverse of A times B. Okay, and remember to keep in mind A inverse times B is not the same thing as B times A inverse. Alright, so what we're going to do next is I'm going to give you a system of equations, and for part A, you're going to write it as a matrix equation. Okay, so here's the system. Your system is -2y plus 2z equals 12. 3x plus y plus 3z equals -2. And x minus 2y plus 3z equals 8. Okay, so for part A, you're going to write the system of equations as a matrix equation. I'm going to give you some time to do that. Got my last one. Jeez. That's your first one, right? Okay, so remember, we already looked at matrix equations in slide 21, right? This is equivalent to the matrix equation, so this is what your setup should look like. So don't just do the coefficient matrix, that's just going to be the first one. Okay, and then Logan E, can you tell me what your first column is here? Did you do that as your first row? Not the column? Okay. What'd you get for your second row? Okay, and the last one? Good. Okay, and then your second one, you do have to put your X, Y, Z. All right, and then Alex, what's that going to be equal to? Yep. So it'll be equal to whatever you have equal on your equations. So the first one's equal to what? Yep. And then the next one. And the last one. Okay, so this is going to be your matrix equation. So this is your A times your X equals B. How do we do? Good? Sorry. I don't think I told you you had it right. I said now you have to put your X, Y, and Z in there. Oh, okay, so yeah, so how do you know what each column consists of? So the first column is all coefficients of what? X. Okay, so Logan, did you fix it? So did you have your X's going horizontally? Okay, so in the first column should be all the coefficients of your X's. So is there an X in the first equation? Nope, so then you have a 0. So for this one, 3 is your coefficient, so that'll go in the second row. And then the last one, 1 is your coefficient. And then the second column is going to be Y's, and then your third column is going to be the coefficients of Z. Okay, so now what we're going to do here is we are going to solve the system by solving the matrix equation. And we are going to use our calculator for this. So you can use your calculator to find the inverse of A. Okay, so we're going to find it and then we're going to write it down. Alright, you guys ready? Alright, so the first thing we're going to do is go to our matrix. Now, a lot of you probably just have the first one defined. You probably don't have B defined, right? Okay, so we're going to go over to edit. Okay, and for A, I'm going to edit A. So I want A to be a 3 by 3. So you would type in 3 by 3. And then we're going to go ahead and type in our matrix A, which is right here. So 0, enter, -2, enter, 2, enter. And then we're going to keep going. So 3, 1, 3. Okay, and then once you have that in there, then you can find the inverse. Do you need another second to get all your entries in, or are you good? Good? Okay, so now we have to quit. So go to second quit. And then we're going to go back to our matrix, and we're going to select matrix A. And then the button that we push to get to the matrix is actually the inverse button. See how it says X with a little -1 on it? If we push that, that shows us A inverse. And if we click enter, we will get the inverse matrix. Uh-huh. No. But for these you can, yes. So you're going to have to go back to matrix and then select A. Okay, so if you go back to matrix and then you press enter, so you get A, then you can hit the inverse button. This is the inverse button here. And then you should have A inverse, and then you can just press enter. That's your A inverse, yeah? That's your inverse. Okay, so what we have to do is we have to find x. So we know that x is going to equal A inverse times B. So x is going to equal, and you don't have to write the whole matrix again. It's going to be the A inverse matrix times B, and our matrix that's B is right here. Okay, and this should work because A inverse is a 3 by 3. This is a 3 by 1. So my final answer should be a 3 by 1. Okay, so now I have to input B. So I'm going to go back to matrix. I'm going to arrow over to edit. And now instead of editing A, I want to edit B. So B is going to be a 3 by 1 matrix. Okay, and then I'll show you how you can multiply them together. So again, just make sure that you do the A inverse first. So I'm going to go to second quit. I'm going to go to second matrix. I'm going to do A inverse. I'm not going to press enter yet. And then I'll just do multiplied by. And then you have to go back to the matrix and select B. So you have A inverse times B.
Can you actually express those stuff
That
as
the times, yep. Okay, so then this is going to be x equals negative 20, 10, and 16. That there's going to be different sections. Okay, so this is going to be your final answer. That's going to be your x. So really, you should notice that in order to solve these, we're already using things we already learned how to do. So first we learned how to do by hand the inverse, and we've already learned how to do by hand the multiplying. Those would entail both of those things. So you'd find the inverse and then you could multiply. So your homework's a little bit different. The first ones are going to be the same. So numbers 6 and 10 through 18 evens, those are going to be done by hand. So I'm going to be checking for that. And then the second part, you're going to do 30, 32, 33, and 34, but not 31. Okay, and with those you can use your calculator on. Okay, and then while you guys are starting this, I am going to give you back your last homework. Some of you are doing a really good job. Others of you are just rushing through. And I'm specifically checking to make sure you're doing those ones by hand that we talked about. When you get your homework back, you're going to see some of you might have nothing on it. That means you got full credit. And then if you have a score, then you didn't, because it'll have your score on here. Okay, so this is what I'm looking for. I'll just show you this, okay? So like when you're doing your row operations, you have to show me the row operations that you're using. What are you using to get from one to the other? Okay, here's another one. Shh. Okay, here's another one. So I should be able to clearly see from one set to another what you did. Some of you are not putting your row operations at all. If you're not putting your row operations at all, you're losing points because I don't know what you did to get from one row to another. Okay, that's also going to be very important for your test, your short answer portion of your test. So make sure that you're showing all those steps.